Amides. We will, study amides, you and me together, and we'll learn amides. What are amides? Amides are derived from carboxylic acid. It's the first thing. Amides are derived from carboxylic acid. So that's the first thing, guys. You need to know is it is derived from carboxylic acid, and a carboxylic acid. It contains, what does a carboxylic acid contains? Carboxylic acid contains this one's COOH group, yes. And in amide, this OH part of that group is replaced by an NH2 group. So this is the difference. You see that this is OH is replaced by NH2 group. So what are amides then? Amides CONH2. Okay, so amides are like this. Yes, they are amazing. CONH2 with the CONH2. But so in amides, what happened is this is CONH2. Here is no OH, but it's NH2. So that's amazing to know, guys. We're talking about amides. We want to learn. We really love organic chemistry. Yes, you and me both. We really love. We only learn things if we love them. So this is a lovely guy coming now. Some simple amides. We're talking about some simple amides now. The most common discussed, amide is ethanamide. So this is the most common discussed amide, which is ethanamide. I show you this guy. This is ethanamide. You see, this is ethanamide guy. Yes, ethanamide. Yes, this guy is ethanamide. So what you see here is 2 carbon, due to which we say this is ethanamide. This is 2 carbon. Yes, that's wow. So this is ethanamide. Yes, this is 2 carbon and NH2. Ethanamide. The 3 simple amides are these ones. 3 simple amides. These ones. First one you can see is methanamide, just 1 carbon, and carbonyl group, carbon just 1. There is another carbon which is methyl next to the carbonyl, and you see ethanamide. And the third one is 2 carbon is ethyl group, so it's total 3 carbon including carbonyl. So when you name the amide, you include the carbonyl carbon number as well. So it's 3 carbon, you say propanamide. And now we go further and see what we would learn more. One thing to notice is in each case the name is derived from acid by replacing the oic acid ending by amide. So you replace oic acid by amide, like if this is an acid, it will be here methanoic acid. Instead of amide, it would be methanoic. So you put oic here, okay, this this guy. So oic and acid after that. So what you put here is oic, and if this is acid, carboxylic acid, you will put like this 2 words, oic acid. So this is methanoic acid. This would be then ethanoic acid, and this would be propanoic acid. But no, it is amide. So this is the only difference. Ending by amide is changing this one oic acid and ending by amide. If you want to know about amide, let's go. We learn chemistry. We really love to learn chemistry. These are amazing molecules. Yes. If this chain was branched, now we're talking about branching, and we're talking about your naming. If this chain was branched, the carbon in the CONH2 group counts as a number 1. So now this is the one thing. I mean, if it is a branching, we're talking about amide, and there are too many branching, you don't know how to name them. Yes, branches, and branches, but there is an easy way. A pretty easy way. It's a beautiful way to name it. Yes, that's wow. How? We just gave number 1 to the carbonyl guy. Carbon guy is the winner guy. There's the actual guy, which is showing role. I show you. This is the actual guy, This is the guy, you know, that's amazing, you know. This is the guy you were talking about. So carbonyl guy, so give this carbonyl number 1. So this guy is a number 1, and give other number, you know, to other guys. So number 2, number 3, so ever. So this is total chain is 1, 2, 3, 4. So this will be butane amide. Butane mean it is 4, and at 3 position there is a 1 methyl group, you know, because this is 4 carbon chain total 1, 2, 3, 4, and at 3 number there is a methyl, so you put 3 and then dash and then name and together amide, so 3 methyl butane amide. Now this is naming. We talk about physical properties. Let's see how this melts. First we talk about melting point. Yes, what do you think? What kind of melting point you will expect? You know, amide is, you know, it's very good hydrogen bonding, so we will expect a higher melting point. What do you think? Let's see how these things goes. The first thing, you know, we're learning is that methane amide is liquid at room temperature, because it's a very, you know, lower number amide, mean just 1 carbon, so it's a liquid. So melts at 3 degrees centigrade, but the amide is solid because they have, you know, the bigger molecule is, you know, the more will be the attraction between those molecules, and more the attraction are the chances the molecule is going to be solid. So the ethanamide forms the colorless deliquescent crystals. Even the ethanamide just is crystals and solid with melting point 82. Deliquescent substance. What is that? When we say deliquescent, what's that? Is that substance in which picks up water. I mean, it absorbs water from atmosphere, you know, and then becomes liquid and dissolves in it. So it becomes, you know, so if you expose this guy, ethanamide, which is deliquescent guy, so if you expose these molecules to atmosphere, it will absorb the moisture from atmosphere, and it will melt and will dissolve. So this is the, you know, the word we use is deliquescent. So is this guy, ethanamide is the deliquescent guy. Okay. Picks up water from the atmosphere, and dissolves. Ethanamide crystals nearly always look wet. This is the reasons. So there is a note, ethanamide they decided to smell of mice. In fact, the smell is due to an impurity in the ethanamide called N-methylamide. This is N-methylamide. Why you say this one's N-methylamide? If you see, this is amide, yes, and due to this NH, this is amide. Ethyne amide because it has 2 carbon, but because with nitrogen there is a 1 methyl group, you can see, so it is N-methylamide. N-methylamide, due to that one, is called smell of mice. Okay, there's impurity here. Where one of the hydrogen in the NH2 group, as I told you, has been replaced by a methyl group. Okay, so that's the only thing, you know, happen here. Now we'll go further. We want to learn more. Yes. So the melting point. So we talk about no melting point. The melting point of amides are higher for the size of the molecules. Mean the melting point is quite higher. Why? And they can form hydrogen bonds due to this reason. The hydrogen atom, you know, is the hydrogen atom is in NH2 group are sufficiently positive. So these hydrogen atom, you know, here they are sufficiently positive because nitrogen is you know, withdrawing electron of the protons just like water. And if something is positive, it forms hydrogen bond, you know, as there is a hydrogen bonding in water due to oxygen molecules next to the hydrogen. So here the same thing happen. So hydrogen bond with a lone pair on the oxygen atom of another molecule. There is a lone pair, you know, on amide. So How many lone pairs? These you can see 2 lone pair. Why 2 lone pair? Means oxygen has the 8 electrons, yes. So in the first orbital will be 2, and the next there would be 6. So out of these 6 electrons, 2 outermost orbit, has 6 electrons. So 2 oxygen is using 2 electrons for a bond with carbon, but it still have 2 lone pairs. So those hydrogen from the amide will form a hydrogen bonding here. So this is NH, and this hydrogen is available to form a bond. Same way this one, and it will form with these lone pairs. These lone pairs will form a bond here. This is called hydrogen bonding. 2 lone pairs on oxygen. If you show you oxygen, here is amide structure. That's an amazing structure. You can see it's 2 lone pair. Yes, 2 lone pair. Yes, ready to form a hydrogen bond. This bond will be with the electropositive atom. That's here hydrogen itself. Amide has these guys, electropositive guys. So hydrogen bonding. So melting point will be higher, and boiling point as well is higher as compared to the number of carbon atoms present in the amides. As you can see, there is a potential for a lot of hydrogen bonds to be formed. Each molecule has 2 slightly positive hydrogen atoms and 2 lone pairs. So slightly positive hydrogen atoms, yes, and 2 and 2 slightly positive hydrogen atoms. Sorry, I have sore throat and cough. Sorry, so if I cough during the video. Each molecule has 2 slightly positive hydrogen atoms and 2 lone pairs on the oxygen atoms. The hydrogen bonds need a reasonable amount of energy to break. So these hydrogen bonds, although there is electropositive, yes, but if you want to break them, reasonable amount of energy you need. These hydrogen bonds, yes, need a reasonable amount of energy to break, and so the melting point of the amides is quite high. They are not free. They have formed a bond with oxygen guys who has lone pairs. So if you want to break them, if you want to break their friendship, you can't break easily. No, not at all. You have to provide energy, sufficient energy, so that, you run, and then eventually they can leave. But it's not easy, It's quite high. So the melting point is quite high. If you